I'm talking about yield. Okay, so what's a yield? In a chemical reaction, basically, when you have two things reacting together to make a third one, you might stick in a certain amount of A and B, and you expect to get 100% C out of that. But the problem is that, let's say, I'm making stuff up here, so 20 grams of A and 40 grams of B, and you might expect to get 60 grams of C. But there are reasons why these reactions don't necessarily go to plan. And the first thing is that it says in the specification, sometimes reactions are reversible. That means as much as A and B are formed, a certain amount of C may decay back into A and B. So sometimes that's the case. Also, some of the product could get lost. So let's say you've done your reaction in your reaction vessel, so it's all there and it's all nicely reacted to C. But C is a powder, so that accumulates at the bottom of the thing, and then you filter it and you manage to trap C. But of course, some of the C might get stuck in the filter, or because there's a certain amount of solubility of the C, there's some C still in solution, so that then goes through there with some of the C is lost through this. Sometimes you also wash it with like distilled water or whatever, just to make sure. But all of that, what that basically means is that you'll probably not get your 60 grams out. You might get, let's say, 55 grams. Okay, so what does that mean for my yield? The third thing is, of course, that in fact you might expect C to form, but you might also get a little bit of something else called D, and D is not something that you want. And so therefore it can contribute to a lower yield, a lower end result, a lower return of C than you might expect. So how do I get the yield out? Well, what you do is what you actually get, that number here, you divide by the theoretical amount that you get. So 60% in this case would be theoretical, and 50% is 55 grams is the actual yield that you've got. So you divide the smaller number by the bigger number, and you times it by 100, and that will give you your percentage yield. So in this case, 92, I've rounded it, 92%. Now that would be a really, really good yield. Most of the time, it's not that good. Okay, so that's something to get used to, but yeah. So it makes sense if you've got 55 is nearly all of it. So it's always the smaller number divided by the bigger number, times it by 100, and that's what gets you your yield. That shouldn't take a lot of thinking about it. That's fine. Now, for the higher tier, you need to calculate the theoretical mass of a product from the given mass of reactant and the balanced equation for the reaction. Since we're dealing with global warming a lot, okay, so we've done this reaction probably quite a few times. So any fuel that contains carbon produces carbon dioxide, and the idea is that carbon in an excess of oxygen reacts with completely with oxygen to give you carbon dioxide. So let's say, how much carbon dioxide do you expect to get out of a combustion of 1,000 kilograms of carbon? Okay. So the reason why this might not produce the expected result is, for example, it's not reversible, but you may in fact not burn all of the carbon in your, let's say you are using wood. Some of the wood may leave some ash, so the expected amount of carbon dioxide may well be smaller. So it's like, I mean, you wouldn't probably think of it in terms of yield because carbon dioxide is not necessarily desirable, but there we are. Okay, so let's say we get 1,000 kilograms of carbon, and we've got an endless amount of and an excess amount of oxygen. We don't know the oxygen. We're not really bothered by that, but what we really want to know is our mass of carbon dioxide that we're producing. So the first thing that we need to do is to say, okay, carbon has a molar mass of 12, so it's 12 grams per mole. And then carbon dioxide has a molar mass of 44. And if you're wondering how I know that, it's because I've done this many, many times. And in some videos that went before, and I've shown you this reaction a few times. So I'm assuming that you're okay to follow that. Carbon is 12 and oxygen is 16. And so if you add 2 oxygens and a carbon, you get to 44. So this basically means that 12 grams of carbon would produce 44 grams of carbon dioxide. And in a similar way, 1,000 kilograms will produce in a ratio however many kilograms of carbon dioxide. So 12 grams will give me 44 grams in the end. Okay, so whatever I have to start off with, which my 1,000 kilograms, will behave in a ratio exactly the same way. So if I divide 12 by 12 and then times it by 44, I get to 44. So I do the same thing on the right hand side where I don't know what my numbers will be. Divided by 12 and times it by 44. Okay. So intuitively you can see that gives me a bigger number on the right hand side. So that's 3,666 point, let's round it there, 7. Okay. So if I multiply it, quick sanity check, if I say 12 times 4 is 48, right? That's 44 is not a million miles away, it's slightly less. So 1,000 times 4 is 4,000 and 3,666.7. It's not a million miles away, it's about the correct number. Okay, so I would expect out of 1,000 kilograms to get 3,666.7 kilograms. And let's say that I've been told that my amount of carbon dioxide I actually get is this, 3,217. It doesn't really matter, I just invented the number. Then it's always the small number divided by the actual, the actual result here divided by the theoretical yield, theoretical being the maximum amount of carbon dioxide in this case that I can get out, and times that by 100 for percentage. That would be 87.7% or thereabouts. I'll do a reversible reaction. So this is called the Haber process, and it has a certain amount of success or a certain yield at different temperatures and different pressures. It needs high pressures and fairly high temperatures in order to work at all. But the higher the temperature, the lower the yield you actually get. So let's say you have a system whereby the hydrogen is actually what costs the money in this process, and the ammonia is what you want. Nitrogen is not very expensive because 80% of the air is nitrogen. Okay, so if we have 600 kilograms of hydrogen, then how much ammonia can I make at maximum? And then we're going to say that a typical yield is something like 25% at the temperature and pressure that we're using. And then we'll see how much we're actually expecting to get out of this. So the first thing that you should do, of course, is calculate the relative formula mass. And that is 1 times 2 is obviously 2. So each hydrogen has a mass of 1. And then you've got 3 lots of that. And that gives you 6 grams. Or a mass of 3 times 2 grams on the left hand side. So if you had 6 grams of the hydrogen, you would react it with an excess of nitrogen, and then you would get your ammonia out of that, which is 14 plus 3 times 1 or 1 times 3. That's the hydrogen in there, so that's 17. Okay, and you've got 2 molecules of that. So in total, it would give you 6 grams of the hydrogen, would give you 34 grams of the nitrogen, of the ammonia, sorry. And that, of course, we can then calculate that's 28 grams of the nitrogen here. And we know intuitively, or not intuitively, maybe, but nitrogen has a mass of 14, and you've got 2 of them, so that's 28. So that fits really nicely. But we don't have 6 grams, we have 600 kilograms. Doesn't really matter. So all we have to do is scale it up. So how do I get from 6 grams to 600 kilograms? Well, again, I can do various things to achieve that. I can say, okay, 600 kilograms is 600,000 grams. And if I divide that by my 6 grams, I know that this is a factor that I need to go up by a factor of 100,000. So in order to get from my 34 grams, I need to apply the same ratio, and 34 times 100,000 is 34 million. Right? No, 3.4 million. Right, 3.4 million. So it's 3,400 kilograms. And that makes intuitively a lot of sense. And of course, these numbers are really quite nice, and that's why I've chosen them. Even though if I'd said you've got 6 grams of hydrogen, that would have been a nicer number still. Okay, so what we can now say is what we need is 25%. So if 3,400 kilograms is my 100%, right? That's my 100%. Then what is 25%? And so again, I do this by ratios every time. Divide it by 100, times it by 25. And of course, you wouldn't write this down after a while. But 3,400 divided by 100, 3,400 divided by 100, times it by 25. That gives you 850 kilograms. So that's kilograms. So my yield would actually be 850 kilograms. Okay. So let's say we've not got nice numbers like this. What we've got is, I'm going to take most of that away. Okay, let's say we've got some awful number, 267 kilograms of hydrogen, and we want to know essentially how much ammonia we get out of that. And our yield is going to be 37% this time. I'm just plucking numbers out of the ether here. Okay, so again, you do the same thing as before. Hydrogen has a mass of 2, and you've got 3 of them there. So that's for 6 grams, you would get 34 grams of the ammonia. And so all you need to do is you need to be able to say, okay, how do I get from 6 to 267? And how do I get from 34 to my x? So now the good news is that actually the molar mass here could be, so if you know that you've got 6 grams, and if you knew that you had 6 kilograms, for example, then you just go like, okay, so that gives you 34 kilograms. So because this is a ratio, and I've said before, ratios don't really have, well, they don't have units. So how do I get from 6 to 267? Well, I can divide 6 by 6 and then times it by 267. So I do the same on the other side. So I go divide it by 6 and times it by 267. Right? Because if I divide the left-hand side by 6 and I times it by 267, I get to 267. And if I do that on the right-hand side, that then gives me the same sort of ratio. Okay, 34 divided by 6 times 267 is 1,000. So my x here is 1,500 13. Now you might say, I don't have any idea whether that's correct or not. Well, if you go from 6 to, let's say, what's a close number there? 6 times 6 would be 36. So it's about 6 times higher. So if you go 250 times 6 is about 1500. So that's roughly correct. That is 100% yield, and we don't have 100%. What we do have is 37% yield. And so 1513 divided by 100 times 37 is 500. I'm going to round this up because it says 559.81. So I'm going to round this up to 560. So 37% is about slightly more than a third. Out of 1500, a third would be about 500. So it's slightly more than 500. So that seems okay. And that's pretty much it. That's all I can think of.
Please like and subscribe and let me know of any questions you'd like me to cover in the comments.